Hello, I'm R Naren from School of Chemical and Biotechnology, SASTRA. This is a short learning capsule as part of the Fluid Mechanics for Process Engineers course that I take at SASTRA. This is learning module 2, and in this module we are going to see what are the typical approaches that we adopt in fluid mechanics, and these approaches that we adopt while studying fluid mechanics problems are based on what is the focus, what we are interested in typically when we analyze a fluid mechanics context. Let me first show you some illustrations and then we'll go to these approaches. This is a very simple sketch of a pipe flow network. I have only captured here the most required essential or the details for this particular learning capsule. You have a tank, let's say, which is indicated as point A, from which the water is drawn by the pump and it is being delivered to another point B. So it's very simple to understand. So water is taken from this reservoir or the underground tank or a lower level tank at A, and then it is delivered to a point B. Now we have seen these examples not only in process industries. This piping network is part and parcel of our life, our home, our institutes, offices where we work, and so on and so forth. So indeed this is of immense value of and practical use of such pipe flow networks. Now when we see this pipe flow network, can you think of what will be the sum of the objectives or some of the questions that can come in our mind, or something that we want to study in this pipe flow network? Now if you can think for a while, now some reason or the reason for which that we are looking in this pipe flow network could be the power consumption, right? We want to know for a given volumetric flow rate how much is the energy rate. So this is the volumetric flow rate. Let's say we want to pump 100 liters per hour, means how much energy should we supply to the pump, how much energy should we invest on the pump if we need to pump this much quantity through this pipe network. So this could be one objective. This could be one possible reason that we are looking in to find an answer in this pipe flow network. Now the other reason could be, like, for example, you have such bends in the pipe flow network. Not only this is the only bend, maybe in this simple sketch I have shown you as one bend, but you definitely know that the piping system runs for at least a few kilometers depending upon the size, the distance that which you want to carry water. Now we could be carrying water right from dams to a settlement area, from a river catchment area to again a city, and then from distributor to towns, and so on and so forth. So this could be really running from few meters, which could be within our home, to a few hundred kilometers also, if it is for a large distribution system. And so do in also industry piping system might be running for at least a few hundred kilometers if you think of a large processing system or a petrochemical or a refinery plant. So you might have lots of such bends. Now probably one of these bends is often getting damaged, or there is a leak, and maybe as an engineer you may want to know what causes this rupture, right? Can you find a mechanistic reason or mechanistic reason or an understanding of failure of these bends? And probably you want to fix it. So that means you want to replace with another bend. You don't want to just like that replace by trial and error. You want to understand how the flow is happening and then you want to replace. Like this, you can add any number of your focal question, the objective for your analysis in a given context. Now one another example I want to show is something like a mixing in a cylindrical tank, which can be used, which we can extend for homogeneous system. Okay, and also for heterogeneous system. What I mean by heterogeneous system is we can use the same principles and apply it for gas liquid system, liquid liquid dispersion, or a solid liquid suspension. Now in all these cases, essentially it contains a cylindrical tank. Okay, so there is typically a shaft, there is typically a baffle attached to it, and it can have the contents. So you may have a liquid filled in this tank, right, and you may have an impeller. Now you can have an impeller with a single shaft or a multiple shaft. Let me just draw it slightly thicker, yeah, so that it's visible. So this is the impeller blade that I'm trying to draw, and this impeller is driven by a motor, okay, over here. Now you can take clue from this, and this could be applied for homogeneous, as I said, heterogeneous. This could be for a batch system, and this can also be made for a continuous system, right, extended to a continuous system if you put probably an inlet and an outlet. Now here again one can think of a different question. One could be again on the power consumption. Right, here the power consumption is not on the pumping of fluid, but it is the power consumption on the impeller. So that means if you want to attain a desired performance characteristic, say in this case of mixing, right, what should be the power consumption for the impeller? What should be the RPM of the impeller? And then corresponding to RPM, you primarily are interested in the energy consumption. And the second question could be like how the design of blades, impeller blades, I mean here, right, affect the fluid motion. Now this could be one fluid motion in the vessel, right. So that means why you have this kind of a blade. What if you have a different kind of blade? How many blades you should have? What is the relation between this blade shape, the number of blades, the thickness of the blades with respect to the motion that is going to be getting induced here? So this could be one another question. Let's not try to find out how to answer these questions. All I'm interested in this learning capsule is think of different questions one would be interested in a fluid mechanic problem. I'll take one more illustration. This is a very simple case. I've just primarily borrowed from the first illustration and just focusing on just the pipe part, which I have extended here. So there is some flow into the pipe and there's a liquid is moving. Now here what could be one question? Now here again one could be asking the power consumption, right. The second question could be based on the design. So that means it could be what diameter of the pipe to be used. Okay, so if I want to fix this flow rate and I have this pumping power to be fixed, then what diameter is the best? So we can have such kind of design question, or one might be very much interested to know how the fluid actually moves in the pipe, right. This could be one question, right. Let us not discard any question. Let us not say this question is good, that question is bad, this is very difficult to answer, and so on and so forth. The idea is to arrive at different kinds of question for the same process, for the same context. I'll stop this module here, but let us think of any other application involving fluid mechanics, fluid motion, right, and think of questions that one would probably have, the focal points that what will be the focus of different person for the same process. And with this we will continue in the next learning capsule. Thanks to all of you for watching this video.